So let's continue with one more example. Find the volume of the solid obtained by rotating the region bounded by the given curves around the y-axis. So as soon as you see y-axis here, you understand that your variable of integration will be dy. Y equal to x square plus 1 is a parabola shifted 1 unit on the top. Y equal to 0 is a line, straight line. X equal to 0, x equal to 2, again straight lines. So try to draw all these 4 curves so you will understand the bounded region. So we can find the volume. So this is your shifted parabola, y equal to x square plus 1. You have x0 and x is 2. So let me draw the x equal to 0 line, that's this one. And you have x equal to 2 line, that's this one. You also have y equal to 0. Y is 0 on this line. So here is the shaded region. But x equal to 0 can be extended further. And to find the line of intersection, the points of intersections, let's try to solve these lines so we know where exactly the line cuts this parabola. So we have y equal to x square plus 1. Rewrite this as x square equal to y minus 1. Suppose you plug in x equal to 2, you know x equal to 2, it's given here. You can choose this point, calculate the y values. You get y equal to 5. So when x is 2, you know the y value is 5, so you know that this value is 5. So at 5, you're good to draw this horizontal line. You can name this as y equal to 5. Now that you know the horizontal line y equal to 5, and also you're finding the region bounded by given curves around the y-axis, you can take a circular disc here where the radius will be this much distance here, radius r. So if you choose any coordinate x comma y on the curve, this radius r will be your x coordinate. So let me rewrite. Radius r here is x coordinate. We want area formula pi x square. And we plug in again for x square, which is y minus 1. Now we find the volume, which is pi r square h. Plug in for r, the radius is 2 times 5. Simplify, all you have is 20 pi. So the volume will be 20 pi. So that is this area here. Let me use 2 different colors. Let me use blue color here. So this is the green plus blue volume. Now let's calculate the volume integral. Y equal to 1 to 5 pi times y minus 1 dy. So this simplifies to 8 pi. And you can identify this as volume of blue region. Now finally you can write the answer. You want the volume of the green region, green shaded region. So you can write the final answer. 20 pi, the green plus blue, minus the blue, which is 8 pi. This will give you 12 pi, which will be the area of the green part. Now we do the washer method. Let's consider rotating a region bounded between the curve f of x and g of x from x equal to a to x equal to b around this x-axis. So here is x equal to a, x equal to b around the x-axis. So we are finding the region bounded by two curves f of x and g of x. That's this region. When we rotate this region, all we get is two disks and this solid region here. So you're seeing a bigger disk and a smaller disk and the same endpoints A and B. So we identify this radius as r sub I, we call it as inner disk, and the one which is with a bigger circle, that's this circle with the larger radius, we call it as outer radius, r sub O. Imagine there are two circles, one outer concentric circle, one inner. The outer one will have a radius RO, the inner one will have a radius RI. So we name this as r sub I is g of x minus 0, so it's still g of x itself. R sub O, we're going to call this as fx minus 0, which is still f of x itself. So you want to imagine your y equal to 0 line here. And here is your y equal to g of x curve. So this distance between this g of x and y equal to 0, this is your r sub I. And that's what you're going to rotate. When you rotate, all you see is the baseline will be 0, and then the top curve will be f of x. So dx is the integral here because you're rotating around x-axis. So let's write the volume formula. X equal to a to b pi r sub 0 square pi r sub I square, and then you have a dx. A to b, pi goes out, f of x minus f of x square minus g of x square. So this is the formula for the washer method. So let's do an example for this washer method. Set up an integral that would give the volume of the solid obtained by rotating the region bounded by the given curves around x-axis. Let's change this as y-axis. So you will see a dy integral in the problem. And let me also change this curves a little bit. Let me do the calculations for x squared plus 1 and x equal to 0, x equal to 2. And let's consider this line to be y equal to 0. So let's try to draw this curve. You have a shifted parabola, 1 unit to the top, and you have lines y equal to 0, x equal to 0, and then you have x equal to 2. This point of intersection between the curve and this line is 2, 5. So you have a horizontal line at 5. And say this will be 1 unit. So this height will be 1 unit. Let's do some shaded region. Now let's calculate this point of intersection, which is similar to our previous calculation. So when you plug in x equal to 2, in this function x square plus 1, all you get is y value 5. That is this point here. So the concentric circles will be this one here, and here is the small radius. So we have bottom of the curve, which is r equal to 2, h equal to 1, and the volume will be pi r square h. So it's pi times 2 square times 1, which is 4 pi. Then we have the top, which is r sub 0, the outer radius, which is x equal to 2 minus x equal to 0. So this is right minus left. This will be 2 minus 0, which is 2. R sub I, the inner radius, will be the parabola, which is x square equal to y minus 1, minus the y-axis, which is the x equal to 0 line. Sorry. So this will be square root y minus 1 if we write in terms of x. So this is x value itself, which is 0. Subtract, you get y minus 1. Now you have r sub I, you have r sub 0. So you're all set to plug in into this volume integral formula, which we derive for the washer problems. Y goes from 1 all the way up to 5. Pi r sub 0 square minus pi r sub I square. And then the variable of integration is dy. So simplify this, plug in your r sub 0, which is 2 square, and plug in your y term, which is square root y minus 1, and then you have a square times dy. Integral is from 1 to 5 y values. This is the square term. 2 square is 4, and the square of a square root is just the term y minus 1. Simplify, all you get is 3 minus y. And when you integrate, plug in the limit, simplify, you get 8 pi. So now finally you can write total volume is 4 pi plus 8 pi, which is 12 pi. One more example. Set up the integral that would give the volume of the solid obtained by rotating the region bounded by the given curves around y equal to 3. Let's change this as x-axis. So again, we have a parabola, straight line, and straight line. So let's rewrite this line as 2y equal to x plus 2 or y equal to 1 plus x over 2. When we plug in x equal to 0, we have y equal to 1. When we plug in y equal to 0, let's rename this